Hello and welcome to our lesson on the dot product from our trigonometry class. This is going to cover section 9.5. We have two formulas to look at in this section. And the first formula I have listed here is the formula for finding the dot product. The dot product is pretty self-explanatory. It says if you want to find the dot product for V and W, you're going to need to multiply their A components, multiply the B components, and then add the results. The second formula is for finding the angle between two vectors. And I'd like to point out what this formula says. It says if you want to find theta, the angle between two vectors, you're going to need to take the inverse cosine of the dot product divided by the magnitudes multiplied. First example, they're going to give us vector V is I minus j, vector W is I plus j, and the instructions want us to find the dot product and the angle between the two vectors. So product means stack them. You want to stack these vectors one on top of the other to find the dot product. And the reason you want to stack them is because that will line up the pieces that go together. So the A values, the coefficient of the I components, 1 times 1 is 1. And the B values, the coefficients of the J components, -1 times 1 is -1. And then you need to add those two results, or in this case, subtract. And we're going to get a dot product of 0. This is important. So important that I'm going to make a note over here. If your dot product is 0, then your vectors are orthogonal. Now, what does that mean? In my opinion, it's a fancy way of saying perpendicular. So if these vectors were to intersect, they would cross at a right angle. So to prove that, we're also going to find the angle between the two vectors, and I predict that we get 90 degrees. Here we go. Doing the inverse cosine of the dot product, which we already know is 0, divided by the magnitudes multiplied. Now, the reason I didn't actually plug into the formulas for magnitude is because the numerator is 0. As long as the denominator is not 0, you're going to get an answer of 0. And I know that those magnitudes are not 0 because the length of those vectors is going to be a positive quantity. So we're going to have the inverse cosine of 0, which is 90 degrees. And that verifies that these vectors are orthogonal. And for our next example, we're going to be given that vector V is the square root of 3i minus j. Vector W is I plus j. And again, they want us to find the dot product and the angle between the two vectors. I said product means stack them. We're going to multiply the A components together. Square root of 3 times 1 is square root of 3. We're going to multiply the B components together. -1 times 1 is -1. And since that expression will not simplify, we're going to leave that in radical form. This is the exact value, simplified. If they need an approximation, you can go to the calculator. Most of the time, they want the exact value, and that's where you would stop here. Now then, let's find the angle between the two vectors. And that formula is the inverse cosine of the dot product divided by the magnitudes multiplied. So the magnitude of vector v is going to be the square root of a squared plus b squared. And the magnitude of vector w is going to be 1 squared plus 1 squared. Plugging into the magnitude formula that we covered in the previous section. And then if I could scroll up just a bit, we're going to have the inverse cosine of square root of 3 minus 1 over. Now to simplify the radicals here, when you square a square root, those cancel. Negative 1 squared is 1, so that's basically going to be 3 plus 1, which is 4. And the square root of 4 is 2. In the second radical expression, 1 plus 1 is 2. And so we're going to leave that square root of 2. Now at this point, I've got something that I can plug into the calculator. And I do want to get that answer in degrees. So we're going to pull up our handy dandy calculator and do the inverse cosine of square root of 3. Make sure to move out from under the radical. Minus 1 over 2 square root of 2. And that's going to give us 75 degrees. So that is going to be the angle between these two vectors. Now, for a little trick to help you verify that you are correct, what we can do real quick is we can sketch the graph of these two vectors using the origin as their initial point. For vector v, we're going to go over square root of 3 and down 1. And the square root of 3 is approximately 1.7, so we're going to go over to about 1.7 and down 1. And that would be a representation of vector v. Now to sketch vector w, that's going to be over 1 up 1. Right there. And then if we could zoom in on that, what we're looking at is this angle theta. Does that appear that it could be 75 degrees? And the answer is yes, because we know that this much in here, this is 45, and then a little bit more would kick us up to 75. Notice it's not perpendicular, it's a little bit less than perpendicular. So that makes us feel good that this angle is 75 degrees just by sketching the graph of the vectors. I think what I would like to do at this point, before we do our last example, is show you that the Casio has the ability to work with the vectors. So if you hit the menu button, this option number 5 is vectors. So we're going to select vectors. And the first thing it's going to prompt you to do is to define your vector. So we're going to define vector A, which is a two-dimensional vector because it has only I and j components. We're going to say it's a two-dimensional vector. And then the first number is the A and the second number is the B. So we've got square root of 3 as our A component and negative 1 as our B component. So that's vector A defined. Then we're going to go to option, define vector, and we're going to define vector B. It, again, is a two-dimensional vector. Vector B here in this case is vector W is 1 and 1. 1 for both A and B. And now we have both of our vectors defined. So if we hit the clear button and then option, you're going to see you can define, edit, you can access any of the vectors you have defined. If we hit the down arrow, it's going to allow us to do the dot product and find the angle between two vectors. So let's do the dot product first. And in order to do that, we're going to go back up and we're going to select vector A first, hitting 3. That's vector A, option down, dot product, puts the dot for the dot product, and then option vector B. And so this is going to do the dot product of V and W. And notice that it gives a decimal approximation, which we can verify that that is square root of 3 minus 1 real quick by typing that in. Square root of 3 minus 1, same value. So even though the dot product on the calculator doesn't give the exact radical answer, it will give the decimal approximation, which means you can use it to verify your exact answer. All right, so let's hit clear. And now let's find the angle between the two vectors. So we want to select angle, and then you're going to put vector A, comma, vector B. So option A, to get the comma, that is shift and close parenthesis, back to option vector B. And this should find the angle between vectors A and B. Remember, we got 75, and it verifies that answer is correct. So that's me showing you that if you have the Casio ClassWiz, you can use it to do the dot product and the angle between two vectors. Remember, it won't necessarily give you the exact answer, but it will verify your results. And then if you need to go back to regular calculation, you just hit menu and number 1, and you're back to the regular mode. Last example, we have vector V is 3i minus 4j, and vector W is 9i minus 12j. And again, we want to find the dot product and the angle between the two vectors. So for the dot product, we're going to multiply the a's together. 3 times 9 is 27. We're going to multiply the b's together. Negative times a negative makes a positive. 4 times 12 is 48. And then adding those up, we're going to get 75. And that is our dot product. Next, for the angle between the two vectors, that's going to be the inverse cosine of the dot product divided by the magnitudes multiplied. 3 squared plus negative 4 squared. Plugging into the magnitude formula twice. 9 squared plus negative 12 squared. And then we need to simplify. So let's scroll up a little bit. And we're going to have the inverse cosine of 75 over. So the first radical is going to be the square root of 25, which is 5. The second radical is going to be 81 plus 144 is 225. And I know the square root of 225 is 15. So what is that going to simplify to? This is getting interesting here. That's the inverse cosine of 75 over 75, which is 1. And the inverse cosine of 1 is 0. Uh-oh, what does that tell me? This is kind of important. If the angle is 0 degrees, that means that these vectors are parallel. So if you get an angle of 0 degrees, that makes the vectors parallel. If you get an angle of 90 degrees, that makes the vectors orthogonal. And any other angle, like in the previous one, 75 degrees, you would say neither. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.